Welcome back to eCoreAcademy, everyone. My name is Anita and I am one of the teachers and co-founders here. As you can see, today I'm bringing to you all a new Algebra 2 lesson. I know this one's been a long time in the making. I made a part 1, but now only I'm making a part 2. I wanted to take a little break to focus on biology because I know our anatomy and physiology course has been very popular, so I wanted to focus on making another science course to kind of supplement the one AJ is already making with anatomy and physiology. So I'm going to take a bit of a break from that because even I need a break from teaching a certain topic for a really long time. And I thought, what better way than to do some Algebra 2 problems with all of you. So today, as you can see, I'm making the second part to the complex numbers mini-series. It's going to be part 2. And in the last part, we kind of learned about what the complex number system is, and we learned about what imaginary numbers are with I. Now we're going to be performing operations with complex numbers. And right before I get started with this lesson, where we're going to be doing things like addition, subtraction, multiplication, division, finding conjugates, factoring, and solving quadratic equations with these complex numbers, just want to quickly go over what we learned in the last video because it's been a very long time. So remember, complex numbers are written in the form a plus bi. Remember, a is the real part, so it can be any real number we know. It can be any integer, decimal, real number that we know. For example, it can be -1/2, it can be 3, it can be 4, it can be 5, it can be 100. So this is the real number. Over here, this whole part, the bi, this is going to be the imaginary part. So I'm just going to write imaginary. And b is just like a coefficient. I is really your imaginary part. And remember, I is equal to the square root of -1. So whenever we have, remember, when we always have a negative number under a square root, we don't have a real number. So there is really no solution to the square root of -1 in the real number system. But in the imaginary number system, we represent this as I. Remember, I squared is technically equal to I times I. Remember, I is equal to the root -1. So it's technically root -1 times root -1, which is equal to -1. So therefore, I squared is equal to -1. Just keep that in mind. Remember, this is just a quick recap of what we went over in the last video. We also went over the absolute value. So if we have something like the absolute value of a plus b, I'm writing at the bottom of the screen, a plus bi, this is technically equal to the square root of a squared plus b squared. So we kind of ignore the I and we take the square root of a squared plus b squared to be able to determine this. And you're always going to get a real number. So, for example, you might get the square root of, 74, or you might get 5 if you get something like root 25. So that will be real, and that's derived from the Pythagorean theorem. If you don't know what that is, please visit my last video. It'll be in the description box where all of this is covered. Okay, so now let's actually move into the video I have planned for today. Before we do, I would really appreciate it if you hit the like button, there's a subscribe button, the post notification bell, if you also dropped a comment down below, and shared this video using your socials. Okay, so let's get into the first slide. We're going to be doing the most basic operation, which is addition and subtraction. We're going to be combining them in this problem. So here's the problem. We have parentheses kind of grouping the two different parts of our problem. We have 6 minus 8i in one set of parentheses minus the quantity -7 plus 3i. And here's the solution. And before we get into the solution, I actually included this hint. You want to combine the real imaginary parts because remember, our complex number is a plus bi. So we want to combine our a's together, if you want to think of it this way, and we want to combine our bi's together. So here we have one a plus bi kind of set, and we have another a plus bi kind of set. So if this 6 is a and this 8i is bi, and then we have -7 as our a, and then 3i as our bi, we want to combine the a's and we want to combine the bi's together. So that's what we mean by combine the real and imaginary parts. Here's a solution already pre-written for you. If you want to go ahead and copy that down, feel free to do so. I'll give you a second to pause the video. Okay, hopefully that was enough time for you to pause the video and copy it down if you wanted to do that. Now I'm going to be going through that exact same solution, but I'm going to be writing it out and explaining to you as we go. So first, I'm going to rewrite the actual problem. We have 6 minus 8i minus the quantity -7 plus 3i. The first thing we want to do is get rid of these parentheses. So we can pretty much just remove 6 minus 8i from these parentheses because we don't really have a number in front of the parentheses to distribute to these two values. So you can just remove them from the parentheses. We end up getting this is equal to 6 minus 8i. If you come over here, we could do the same thing with the second set of parentheses, but we have this negative in front of it. If we had plus, then we wouldn't have to worry. We could just rewrite negative 7 plus 3i down here. But because we have this negative, we can think of it as negative 1. If we have any number in front of the parentheses other than positive 1, so just a plus sign, we got to distribute it across any numbers that are in this set of parentheses. So we got to distribute this negative sign to the negative 7, and we got to distribute it to the 3i. So then technically negative 1 times negative 7 is positive 7, so we get plus 7. Negative 1 times positive 3i is equal to negative 3i. So this is how we rewrite it. Next, we want to combine the real and imaginary parts. So remember, we're combining our a's, so 6 and 7. 6 plus, what we're going to do first is we're going to actually kind of rearrange this so that we get our a's next to each other and we get our bi's next to each other. So we're going to rewrite this as 6, but we're going to move the 7 in front of the negative 8i. So we're going to get plus 7. We're going to move the negative 8i after, and then we'll have the negative 3i at the end. And lastly, we just want to combine the real and imaginary parts. 6 plus 7 is 13. And then negative 8i minus 3i is negative 11. And then we have to add the I. Don't forget. Think of the I almost like as an X. And that'll just make this so much easier for you because all of you already know how to do algebra and just basic algebra with X. So think of the I as X. So this right here would be our final answer. 13 minus 11i. Okay, that was kind of easy actually. So next, let's kind of bump it up and do some multiplication. And I'll show you exactly how to do that. So here's the problem. We have 9 plus 5i in one set of parentheses, but we don't have an addition or subtraction sign between them. Instead, just two parentheses right next to each other. And remember, what this means is that we're multiplying the two expressions together. So we have 9 plus 5i times negative 2 minus 4i. Here's the solution. It's actually quite simple. You just want to FOIL. So remember, FOIL means first, outer, inner, last. So I'm just going to write FOIL up here. I know this is a method that kind of your parents learned, but I think it's important to remember. So first means we multiply 9 times the negative 2, then outer. So the outermost one is 9, and the outermost one in the second set of parentheses is negative 4i. We multiply those together. Then we do the inner values, so 5i and negative 2, because they're the inner values. Then we do last. So we do 5i times the last value that's left, which is 4i. And then we get these four quantities, and we just combine the real and imaginary parts together. And I'll show you, there's actually something special in the solution, because if you see right here, we have I squared. And remember, if we have I squared, this is actually equal to a real number. This is equal to negative 1. So we can rewrite I squared as negative 1, because remember, we're trying to simplify these as much as we possibly can. So I'll show you exactly how to write this, how to actually solve this problem. So again, like we do with all our problems, we're going to rewrite it. 9 plus 5i times negative 2 minus 4i. Then we're going to do first. So 9 times negative 2 is negative 18. We're going to do outer. So 9 times negative 4 is equal to negative 36i. Afterwards, we will do inner. So 5i times negative 2, which is negative 10i. And then we will do last. So 5i times negative 4i is equal to negative 20. Here's the part that's kind of tricky, because if you see, we have I here. We have another I here. So we multiply the 5 times the 4, but we cannot ignore the I. We can't just write a simple I here. We can't just ignore the fact that there is an I. So I times I is technically I squared. For example, if we had something like x, because like I told you, think of it like x. So x times x is equal to x squared. Similarly, I times I is equal to I squared. So you need to acknowledge that I squared, and we'll just kind of tag it to the negative 20. So where do we go about from here? So I'm going to rewrite this. So remember, as of right now, negative 18 is the only real number in this whole long expression. And what we're going to do is we're going to actually rewrite negative 18, but we're going to take this negative 20 I squared, we're going to move it right after the negative 18. And I'm going to show you why. So I'm going to write the negative 20. Remember, I squared is equal to negative 1. So I'm going to replace the I squared with a negative 1. So technically, it's not negative 20 times I squared. It's technically negative 20 times negative 1. Then I'm just going to add the negative 36i. minus 10i. And you're going to see this I squared come up when you do multiplication, so you need to keep an eye out for it. Did you see how I said I and I? Afterwards, you're going to get the negative 18. And then negative 20 times negative 1 is positive 20. So plus 20 minus 36i minus 10i. And afterwards, now we just have to simplify this so that we get our real and imaginary parts. So we're going to combine our real parts, which is negative 18 and 20. Negative 18 plus 20 is equal to 2. And negative 36 minus 10 is equal to negative 46. And don't forget the i's, because that's the imaginary part. This right here is our final answer. That's how we got to that answer. Let's look at our next problem. This is called complex conjugates, and I'll explain it to you. So here's the problem. We have negative 4 plus I in one set of parentheses, and we're doing multiplication again. And this time we're multiplying it times negative 4 minus I. So if you look at these two set of parentheses, the only difference is the sign change right here. We have negative 4 plus I. Here we have negative 4 minus I, pardon me. And here's the solution. So just take a second and copy that down if you want to. Okay, hopefully that was enough time to copy it down. I'll be going through it with you now. So what we're going to do is we're going to rewrite the problem as negative 4 plus I times negative 4 minus I. And I know I wrote complex conjugates up here, so don't get daunted by that word. We're going to solve this as we normally would, and then I'll be showing you a key concept after we solve it. First, what we're going to do is we're just going to FOIL this, because remember, that's the concept we're going to use whenever we have complex numbers multiplied together. So we're going to have negative 4 times negative 4, remember, first, so that's going to equal 16. Then we're going to have outer, so negative 4 times negative I is going to give us plus 4i. Then we are going to have inner, so I times negative 4, that's just going to give us negative 4i. And then we're going to have last. So positive I times negative I is going to give us a negative, because positive times negative is negative. Because we have two i's multiplied together, we're going to get I squared. So minus I squared. Remember, you're always going to get that I squared whenever you multiply. Afterwards, what we're going to do is, remember, the four i's are the imaginary part, but this I squared is actually negative 1. So this is real. So what we're going to do is we're going to keep 16 at the front. We're going to move this negative I squared to the front. We're going to have minus. Remember, I squared is equal to negative 1. This is the tricky part. You can't get messed up with the signs. So this is negative I squared. So it's technically negative 1 because I squared is negative 1. So negative times negative 1 is going to give you positive 1. So that's why I wrote it like this. I want to show you each step. And let's add the plus 4i minus 4i to the end. And hopefully you're seeing where this is going. Afterwards, what we're going to do is we're just going to have 16. Like I said, negative times negative is positive, so this becomes plus 1. Then we get plus 4i minus 4i. And I don't know if you all noticed, but here we have plus 4i, so we're adding 4i. We have minus 4i, so we're subtracting 4i. So technically, these cancel out. So we don't have an I term at all anymore. And we just rewrite this 16 plus 1. That's all that's left. We get 17. That is our answer. So that is how you get that answer. So if you see, this is the key concept. It's called the complex conjugates. So it's just like the difference of squares. Remember, difference of squares, it'll look something like this. X squared minus 4. So it's just like the difference of squares, the imaginary numbers cancel out. So the difference of squares is where you have two squares, for example, x squared, and then you have 4, and they're both squares. The square root of x squared is x, and the square root of 4 is 2. And what happens is, if I actually write this out, I'll get something like x plus 2 times x minus 2. If you see what happens, if I do FOIL, so x times x is x squared. Then x times negative 2 is negative 2x. Then 2 times x is plus 2x. Sorry, I forgot to write the squared up here. And then 2 times negative 2 is minus 4. These two middle terms, sorry, I keep forgetting to write the x. These two middle terms cancel out, and we end up getting x squared minus 4x, which is x squared minus 4, which is the difference of two squares. So just like the difference of two squares, you can think of it that way. In complex conjugates, the imaginary numbers cancel out, just like the middle term, which is the 2x in this case, which is just going to be the x, whichever the x in this case, the middle terms, they will cancel out. So that's why I'm trying to draw the comparison. If you remember, a difference of squares. So whenever you have a scenario with a plus bi, which are like our normal complex number, and you have it multiplied times a minus bi, so everything is the exact same. Your a value is the exact same, your b value is the exact same, and I obviously stays the same. It's just that you're changing the sign that separates the real number part from the imaginary number part. We call those complex conjugates. You can think of conjugates like opposite pairs. So in this case, a plus bi times a minus bi are complex conjugates. Just remember that. And remember that when you multiply the complex conjugates together, you're always going to get a real number, because what's going to happen is, remember, when you multiply, you're going to get that I squared term, and that ends up becoming -1, or whatever it ends up being, because remember, I squared simplifies to -1. You can multiply that times the coefficient, you'll get a real number. And then in this case, when we have just the I terms will cancel out. So at the end of the day, you're just going to end up getting a real number. So just keep that in mind when you work with complex conjugates and multiplication. And they don't just come in handy with multiplication, and I'll show you exactly what I mean by that. Here's our next problem. We're going to do a bit of division. So let me just pull up the problem. So here's the problem. And I wrote it like this because it's like I wrote it like downward, so I wrote it like long down the page. So I'll show you when I show you the solution. Here's the problem. We have 5 minus 2i. This is actually a division sign, so I'm going to rewrite this right under it, because with the formatting, I have to write it this way. So this is technically 5 minus 2i over 3 plus 4i. So this is the problem. Here is the solution pre-written for you. I'll give you a second to copy that down if you want. And now I'm going to go through the solution with you. So let's rewrite the problem. So we have 5 minus 2i over 3 plus 4i. The first step we're going to take is, because this has a denominator, what we're going to do is we are going to do 5 minus 2i. So I'm pretty much just rewriting the original problem, 5 minus 2i over 3 plus 4i. And we are going to multiply this times the conjugate, the complex conjugate of the denominator. So we're going to multiply 5 minus 2i divided by 3 plus 4i times 3 minus 4i over 3 minus 4i. And this is what you do when you cannot simplify, because the denominator, you cannot simplify this. So to simplify, what we do is we multiply by the complex conjugate of the denominator. So that's exactly what we are going to do. So now what we're going to do is we are going to FOIL. And what we're going to do is pretend we're multiplying 5, well, we technically are, 5 minus 2i times 3 minus 4i in the numerator, and then 3 plus 4i times 3 minus 4i in the denominator. So what happens is we get 5 times 3. We're just going to FOIL it. 5 times 3, which is 15. 5 times negative 4i, which is minus 20i. Then we're going to do inner, so negative 2i times 3, which is negative 6i. And then lastly, we get negative 2i times negative 4i, which gives us positive 8i squared. And then we got to do the same thing for the denominator, the complex conjugates. We get 3 times 3 is 9. 3 times negative 4 is negative 12i. Then we get inner, 4i times 3 gets us 12i, and then lastly we do outer. So 4i times negative 4i gives us negative 16i squared. And then what happens is these guys cancel out right here. So because remember, the inner terms will cancel out, and technically negative 16i squared is, I'm just going to write it over here, negative 16i squared is technically negative 16 times negative 1, because remember, I squared is negative 1, and this is equal to negative times negative 16. So we can rewrite this whole problem as, actually, let's simplify the top part of this problem. So we get 15. Let's combine the imaginary terms. So negative 20i minus negative 6i gives us negative 26i. We can rewrite the plus 8, and remember we have another I squared up here, so we can rewrite this as negative 1. And in the denominator, we end up getting 9. Remember, carry this 9 down. The 12 i's cancel out because they have opposite signs, and then we said this negative 16i squared is equal to negative 16. Positive 16, so we get plus 16. If we continue to simplify, we get 15 minus 26i. And remember, 8 times negative 1 is just negative 8. And then we have in the denominator 9 plus 16, which is equal to 25. And the very last step is just combining the real parts, the real numbers in the numerator. So 15 minus 8 is equal to 7. We have that negative 26i, which is already simplified. All of this over 25, and this right here is going to be our final answer. Okay, so that's how you do division. And you can clearly see how we use complex conjugates in this problem. So we're going to continue, and we're going to do factoring and solving. So I'm going to show you two ways to solve the exact same problem. One is going to use the quadratic formula, which we learned in a previous video. Hopefully you watched that, and then I'm going to show you how to factor it, and they both involve this concept of complex numbers. So the problem here is 2x squared plus 32. Looks pretty simple. What I should add, is equal to 0. So we're trying to actually factor this and then solve for x. Here is the solution pre-written. If you want a second to copy that down, please feel free to do so, and then I'll go through it with you. Okay, hopefully that was enough time to copy it down if you wanted to. So the first step is obviously going to be rewriting the problem. I feel like this is very important because it actually gives you a second to look at the problem and just come up with a method of attacking it. So trying to find a way that you want to solve this. So what I'm going to do first is I'm going to show you how to solve this using the quadratic formula. And I know I wrote factoring up here, and you're all probably going to come at me and say, oh, you're supposed to show us how to factor it. I will get to the factoring. Let me first show you how to do this using the quadratic formula, because something I want to tell you all is the quadratic formula is never wrong. So even if you come up with a quadratic equation that is factorable, you can always make sure that you got the right solutions by plugging it into the quadratic formula, because like I said, the quadratic formula is never wrong. So let's do the quadratic formula first. Please remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. Remember, this is the quadratic formula. Hopefully you have this memorized. And what we're going to do is we're just going to plug the values in. So over here, I'm just going to write it off to the side. A in this case is equal to 2, because it's next to our x squared term. We don't have a b because we don't just have an x term. So b is technically equal to 0, and c, which is just our constant, is equal to 32. So knowing this, we can plug these values into the quadratic formula. Next, we are going to plug them in. So negative b, which is technically just negative 0, if you want to put it that way, plus or minus the square root of b squared, which is just 0 squared, minus 4 times a, which is 2, times c, which is 32. And I should probably extend that. Okay, yeah, over 2a, so 2 times 2, because a is 2. And then we just want to work on simplifying this. So negative 0 is just 0. So 0 plus or minus the square root. And I actually simplified all of this for you. You guys can write out the work if you want to, but I just did this ahead of time because by now you should know how to do this. So 0 squared is obviously 0, and 4 times 2 is 8, and 8 times 32 is 256. So technically you get 0 minus 256. So under this square root sign, you're going to get negative 256 because you're subtracting 256 you got over here from 0. And then you're going to have all of this over 2 times 2, which is 4. And what's going to happen is you're going to get this equal. So we don't have to worry about the 0 anymore, so I'm going to stop writing that 0. We get plus or minus the square, sorry, not the square root. We're already taking the square root. Let me just erase that quickly. Plus or minus the square root of negative 256. And this is technically going to be the square root of negative 256 is equal to the square root of negative 1 times the square root of 256. We pulled that negative 1 out because in the real number system, there is no solution to this because we don't square root negative numbers. But because it is the complex number system, remember, this is technically equal to the square root of negative 1 times the square root of 256. And remember, the square root of negative 1 is I, and the square root of 256 is 16. So this actually comes out nicely. So we get 16 from the square root of 256, and we get I from the square root of negative 1. So we get 6 plus or minus 16I, and don't forget the 4 in the denominator over 4. We can simplify this to positive or negative 4i. And that is our answer. So we have two answers, positive or negative 4i. Now I'm going to show you how to factor this over here. So what we want to do first, we want to pull out the 2 because we want to try our best to make the coefficient of our x squared term 1. We can easily pull out 2 from here. So if we factor out the 2, we get 2 times x squared, GCF the 2. 2 times x squared plus, not 32. Remember, you have to do, this is a common mistake I actually make too. You gotta divide both of the terms by 2. So x squared divided by 2, 2x squared divided by 2 is x squared, which I wrote here, and 32 divided by 2 is 16, which is equal to 0. And what we can do here is, because we know this is equal to 0, we can divide both sides of the equation by 2. And what we get is, we get both sides of the equation divided by 2. We divide by 2, we get rid of the 2 on this side of the equation, and 0 divided by any number is just equal to 0. So then we end up getting rid of the 2 and get x squared plus 16 is just equal to 0. We can go about solving this normally. We want to get x squared by itself. So we get x squared, we got to subtract the 16 from both sides. X squared is equal to negative 16. And what happens here, as you can all see, we have to square root both sides of the equation to get x by itself. So if we square root x squared, we get x. But if we square root negative 16, we get negative 16 under a square root sign, and that just doesn't work in the real number system. Therefore, we got to square root negative 1 times the square root of negative 16. The square root of negative 1 is I, and the square root of 16 is 4. So again, we end up getting 4i, but remember, this can be positive or negative 4i. Because when we solve, when you solve, you need to mention all solutions. So you can't just mention the principal root, you got to mention both of the solutions. The answer here would be 4i. And this actually works out. So if we could rewrite this original equation up here, 2 times x squared plus 16 equals I, we can rewrite this as 2 times x plus 4i times x minus 4i. So remember, complex conjugates is equal to 0. So I just want to show you that quick problem. It's not actually quick, but I'm just saying quick. Let's go to the next problem. We're going to talk about imaginary solutions. So it's very similar to what we just did. We're going to be using the quadratic formula. Here's the problem. We've got 3x squared minus x plus 2 equals 0. Let's quickly identify the different parts of this. So a is equal to 3. B is equal to negative 1. And c is equal to 2. So just by looking at an equation, a quadratic equation in standard form, you should be able to derive that information. And remember, you should have the quadratic formula memorized. Here's the solution already pre-written for you. So if you want to copy that down, feel free to do so, and I'll go through the exact same problem with you again. Okay, hopefully that was enough time to pause the video. So because we already did a problem like this, I'm probably going to go through this kind of quickly. So I'm going to rewrite the actual problem and go 3x squared minus x plus 2 equals 0. And just for the sake of those of you who don't remember the quadratic formula, it's negative b plus or minus the square root of b squared minus 4ac over 2a. See how easily it comes after you've done it so many times? Trust me, it'll come easy to you as well. And we want to substitute these a, b, c values that we have from our actual problem into the quadratic formula. So we're going to write this as, so our b value is negative 1. And we're trying to find the negative value of b. So we're trying to find the value of negative 1. We can just rewrite this as 1. So little things like that you should be able to do in your head just to save you time. Then we have b squared, which is negative 1 squared, minus 4 times a, which is 3, times c, which is 2, all over 2a. So 2 times 3. Next, we're just going to simplify this in one shot. Again, I'm just going to be very quick in the way I simplify. I'm not even going to write out all the different multiplication. So negative 1 squared is equal to 1. 4 times 3 is 12. 12 times 2 is 24. And then we end up getting 1 minus 24, and that's going to give us negative 23. So I was able to solve everything under that under that radical sign, And then we get over 6 because 2 times 3 is 6. And then we end up getting, so we can't leave this negative 23 underneath the square root symbol. So what we got to do is we can rewrite this. I'm going to write it over to the side over here. we can rewrite the square root of negative 23 as equal to the square root of negative 1 times the square root of 23. Remember, square root of negative 1 is I, so we end up getting 23. I'm getting ahead of myself here. Let me erase that quickly. We will end up getting I times the root 20 times root 23 because 23 can't be simplified. So then our final answer is going to be 1 plus I times root 23 over 6. So that is how we solve that problem. Very similar to how we did the quadratic formula with the last problem. Okay, so moving on to the final problem. I know this is kind of a long video, but I think doing all these operations with complex numbers will put them in context for you, because you're not going to be asked for definitions and things like that and basic things on an actual assessment. You will be given problems like this and maybe even word problems. So I think this is very important. So here's our next problem. It looks a lot shorter, and it is going to be a bit shorter than the last problem. Again, just like the last problem, we set this equal to 0. So we set this equal to 0 because we're solving for x. In this case, we're not going to be using the quadratic formula. So at this point, you should know when you look at a quadratic equation if you're going to be using the quadratic formula. In this case, we don't need to use it. So I'm not going to write out what a, b, and c are equal to. So we're just going to get right into the solution. Here's the solution pre-written if you want to copy it down. So hopefully that was enough time to copy it down, because I'm going to go through it again with you. First, we're going to rewrite the problem, which is 8x squared plus 64 equals 0. And remember, when we're solving, we're setting these quadratic equations equal to 0, and we're trying to find all possible values of x that satisfy this. So what we're going to do next is we want to get x by itself. To do that, the first step would be to subtract 64 from both sides. So we get 8x squared is equal to negative 64, because 0 minus 64 is negative 64. Then we want to get these x squared by itself, so we're going to divide both sides by 8. If we divide the left side by 8, we just get x squared. If we divide the right side by 8, we get negative 8. And lastly, we want to square root both sides. If we square root the left side of the equation, we get x. If we square root the right side of the equation, we get negative root 8. And this actually poses a problem, because we cannot just leave this negative sign underneath the square root symbol. So what we're going to do is we're going to rewrite this. So x is equal to the square root of negative 8. But we're going to rewrite this as the square root of negative 8 as the square root of negative 1 times the square root of 4 times the square root of 2. If you remember from my last video, what we do in these instances is we try to break up the number that is under the radical sign, which is this number here is the radicand. So we're trying to break this number up. So that's what we did here. So we have 4 times 2, which is 8, and then 8 times negative 1 is negative 8, which gives us our actual radicand. And what we're going to do next is we are going to see if we can further break this down. So the square root of negative 1, remember, is I. The square root of 4 is 2. And then the square root of negative 2, that can't be simplified further, so we're going to leave that as root 2. And our final answer we are going to get is we're going to rewrite this in the proper form. So we're going to have our 2 come first, and our I, then our root 2. And this right here is the answer. So that's how you would solve that problem. We're finding imaginary solutions like the last problem, but in this case we didn't use the quadratic formula. So that's all I have for you today. I hope you enjoyed the video. I really enjoyed making this because, as you know, I love going through problems with all of you because I feel like it's really hands-on when I write. So please definitely leave a comment down below if you found this video helpful and you found my explanations helpful. If you all like this hands-on method, I will try to incorporate this more into my lessons rather than just lecturing or reading key concepts or just explaining stuff to you. I will try to incorporate more problems. Just let me know in the comments again. Alright, that's all I have. Like I said before, we would really appreciate it if you could like this video, subscribe to our channel, hit the post notification bell, drop that comment down below, and share using our socials, Facebook, Twitter, and Instagram, all of which can be found in the description box. Additionally, if you have any personal or business correspondences, please email us at eCoreAcademy@gmail.com, and we have a website up. You can check it out as www.eCoreAcademy.org. It has a bunch of cool functionalities, and we're currently populating it with notes and quizzes to help you study and go through our courses. Again, that's all I have for you today. Please look forward to my next Algebra 2 video, and I'll be seeing all you bright students soon. Bye!